Let's do the last two examples in this lecture. If we look at the first expression, we have a binomial, two terms, the difference. So far so good, but each term is not a perfect square. So definitely we need to take out the greatest common factor, apparently. And the greatest common factor is 18. It's only a numerical factor, no variables attached to this common factor. And then 72 divided by 18 is 4. So we have 4 left here. And the second term is just x squared. And to identify a and b for the expression inside is easy. A is apparently equals to 2 and b equal to x. And again, keeping 18 as part of our final answer, we write 2 minus or plus x, 2 minus x. And this is our final answer for this problem. So please remember to first think about the greatest common factor in order to be able to factor out the difference of two squares. Now let's do the last problem. First identify a and b, because this is a binomial, the difference here, both terms are perfect squares, so we can now identify the monomials that we need to square in order to get each term. So a is apparently 9x squared, because when we take our a and square it, we will get 81 x to the fourth. And b is obviously 4. So we can write 9x squared plus 4, 9x squared minus 4. And it seems a nice answer, but don't hurry. Consider very carefully each term. This term, even though it's a binomial and each term is a perfect square, we have a sum here. So this term is prime. We cannot factor it any further. But the things are different with this term. It's again a difference of two squares. And in this case, our a is 3x and our b is 2. This is called a repeated factorization, as we discussed in class. So first we keep our prime term unchanged, and we continue factoring, doing repeated factorization, and the answer here is 3x plus 2, 3x minus 2. This is our final answer, and it has 3 binomials multiplied by each other. So the answer is a product of 3 binomials. This is our final answer.